Hi everyone. Welcome. I'm so glad you're here. Settling in, getting comfortable, letting the day slowly drift away from you. Tonight, we're going to spend some time together, thinking about something very peaceful, very quiet, and very, very old. We're going to talk about deserts, and we can take a moment to notice how even the word itself feels calm. Desert, it carries with it a kind of stillness, a quietness, the image of a wide open golden space, stretching out toward a soft horizon, under a slow, enormous sky. Deserts are not scary places. They are not empty places. They are, in fact, some of the most fascinating places on our entire planet. They're full of science, full of slow and gentle processes, full of things happening very, very quietly, over enormous stretches of time. And tonight, we're going to explore all of that, slowly, gently, with no rush at all. There is no need to rush. Everything we talk about tonight will come to you softly, one thought at a time, like sand settling on the floor of a quiet dune. So close your eyes if you'd like, or let them grow heavy, and simply let the words wash gently over you. Let's begin. Fact 1. The word desert comes from a very old Latin word that means abandoned or left behind. It is a word that carries a sense of quietness, of solitude, of wide open space with very little noise. But what scientists mean when they say the word desert is something very specific and very interesting. A desert, in scientific terms, is simply any place on Earth that receives less than 250 millimeters, or about 10 inches, of precipitation each year. Precipitation means any water that falls from the sky. Rain, snow, fog, dew, it all counts. So a desert is not defined by its heat, or its sand, or its golden color. It is defined simply by how little water it receives. And when you understand this, you begin to realize that deserts are everywhere, even in places you might not expect. Slowly, gently. Fact 2. Because deserts are defined only by their low rainfall, and not by their temperature. There are deserts that are extremely cold. In fact, the largest desert on Earth is Antarctica. Antarctica receives so little precipitation each year, because the air there is so very cold and dry, that it qualifies as a desert by every scientific measure. It is a cold desert, covered in ice rather than sand. And it is enormous. It covers about 14 million square kilometers. The Sahara Desert in Africa, which most people picture when they think of a desert, is the largest hot desert in the world. But even the Sahara is smaller than Antarctica. So the next time you think of a desert, you might gently remember that the biggest one of all is white, and cold, and very, very still. And we can take a moment to notice. Fact 3. About 1/3 of the land on Earth's surface is considered desert or very dry land. That is a very large portion of our planet. If you were to look at a map and color in all the deserts, both hot and cold, you would see great patches of dry land stretching across every single continent. Every continent has a desert. Even Europe has desert regions. In parts of Spain and Portugal, where the land is so dry and warm that it meets the scientific definition. The dry lands of Earth are not unusual or rare. They are, in fact, a very normal part of how our planet works. Part of the gentle, ancient breathing of our world's atmosphere and oceans and wind systems. There is no need to rush. Fact 4. The reason deserts exist at all has to do, more than anything else, with the way the Earth spins and tilts, and the way heat moves through the atmosphere. Our planet receives sunlight most intensely near the equator. This is the wide, middle band of Earth that sits closest to the sun at all times of year. Near the equator, the air gets very warm. Warm air rises, and when it rises, it carries moisture with it, rising high up into the atmosphere, where it cools and releases its moisture as rain. This is why rainforests exist near the equator. They receive all of that falling moisture. But the air itself, having given up its water, continues moving, slowly, drifting away from the equator, moving north or south, and eventually, dry and cool, it sinks back down toward the Earth. around 30 degrees latitude north and south of the equator. Fact 5. This sinking of dry air at around 30 degrees latitude is one of the most important reasons why deserts exist where they do. When air sinks, it warms as it compresses, and warm, dry air does not produce rain. It does the opposite. It absorbs moisture from the ground, and the plants, and the soil. This is why the great deserts of the world, the Sahara in Africa, the Arabian Desert, the Sonoran Desert in North America, the Australian Outback, all sit at around this latitude. It is not a coincidence. It is a beautiful, gentle, repeating pattern, set in motion by the physics of heat and air, and the slow rotation of our planet. The Earth creates its dry places and its wet places with great predictability, like breathing in and breathing out, slowly, gently. Fact 6. This pattern of rising and sinking air is called the Hadley cell, named after a quiet English amateur meteorologist named George Hadley, who described it in the year 1735. George Hadley sat and thought carefully about why trade winds blew the way they did, and he worked out that warm air rising near the equator and cool air sinking around 30 degrees latitude was the explanation. He was mostly correct, and his idea has been refined and confirmed over centuries since. It is remarkable to think that a man sitting quietly in 18th century England could think through the movements of air across the entire planet, from pole to pole, and arrive at an answer that we still use today. Science, at its heart, is simply careful, quiet noticing, and we can take a moment to notice. Fact 7. There is another important reason why deserts form, and that reason is mountains. Mountains create what scientists call a rain shadow. When moist air blows in from the ocean and meets a mountain range, it is forced upward. As it rises, it cools, and it releases its moisture as rain or snow on the side of the mountain facing the ocean. By the time the air has crossed the mountain and begins to descend on the other side, it has given up almost all of its water. It is dry, and as it descends, it warms again, absorbing what little moisture remains in the land below it. The land on the far side of a mountain, in the rain shadow, receives very little rain, over thousands of years. This creates a desert. The Gobi Desert in Asia exists partly because of this effect. Sheltered from moist air by the enormous Himalayan mountain range, there is no need to rush. Fact 8. The Atacama Desert in South America is one of the driest places on Earth. It stretches along the western coast of South America, in Chile and Peru, and parts of it receive less than 1 millimeter of rain per year. Some weather stations in the Atacama have never recorded any rainfall at all in all the years they have been operating. The Atacama is dry for two reasons. It sits in the rain shadow of the Andes Mountains, which block moist air from the east, and it is also cooled by a cold ocean current on its western shore, called the Humboldt Current. Cold ocean air does not carry much moisture, so the Atacama is caught between two drying forces, and the result is extraordinary stillness, extraordinary quietness, a landscape that feels, in some ways, like another world entirely, slowly, gently. Fact 9. That cold ocean current we just mentioned, the Humboldt Current, is a remarkable thing. Cold water from deep in the ocean wells up along the coast of South America, making the surface of the sea much colder than you might expect for that latitude. Cold water does not evaporate easily, so very little moisture gets into the air above it. This means that when ocean winds blow toward the coast, they carry almost no water with them, and when those dry winds reach the land, they dry it out even further. Ocean currents, those great, slow rivers of water moving through the sea, have an enormous effect on the climate of nearby land. The Namib Desert in Africa, along the Atlantic coast, is also partly created by cold ocean water. The Benguela Current, which cools the air and prevents moisture from rising into rain clouds. And we can take a moment to notice. Fact 10. The Namib Desert is considered one of the oldest deserts on Earth. Scientists believe it has been a desert for somewhere between 55 and 80 million years. That is an almost incomprehensible amount of time. For reference, the dinosaurs went extinct about 66 million years ago, so the Namib Desert has existed, in some form, for approximately as long as the dinosaurs have been gone. The landscape has been shaped, and smoothed, and carved by wind, and the slow, gentle movement of sand, over millions and millions of years. When you look at the Namib's tall dunes, their smooth orange curves rising against a pale sky, you are looking at something that has been forming since before humans ever existed, since before most of the modern mammals we know today had even evolved. There is no need to rush. Fact 11. Sand dunes are one of the most beautiful and peaceful features of desert landscapes. They are shaped entirely by the wind, and they move. A sand dune is not a permanent, fixed thing. It shifts slowly, as wind picks up sand from one side, called the windward side, and drops it on the other side, called the lee side. Over days, and weeks, and years, a dune migrates across the desert. Some dunes move just a few meters per year. Others can move tens of meters per year. There is something very calming about the idea that even something as seemingly solid and still as a sand dune is gently, quietly moving, creeping across the landscape, like an enormous, very slow, very patient creature, slowly, gently. Fact 12. Not all deserts are covered in sand. In fact, only about 20% of the world's desert land is covered in sand dunes. The majority of desert land is covered in rock, gravel, and bare earth. These rocky deserts have their own name, Reg or Sarir in Arabic, and in scientific language they are sometimes called hamada, or gravel plains. The image most people have of deserts, those graceful rolling dunes of golden sand, is a beautiful image, but it represents only a small portion of desert terrain. Much of the desert world is stone, flat and ancient, stretching out to the horizon. That flatness has its own kind of beauty, its own kind of quiet. A rocky desert under a clear night sky can feel like standing at the edge of the universe, and we can take a moment to notice. Fact 13. The sand in sandy deserts comes from the slow breakdown of rock, over thousands and millions of years, wind, and the tiny expansion and contraction of rock as temperatures change. Very hot in the day, very cold at night, causes rock to crack and crumble, and eventually become smaller and smaller fragments. The smallest fragments, smoothed and rounded by the wind, become sand. Most desert sand is made of a mineral called quartz, which is very hard and resistant to further breakdown. So the quartz grains survive and accumulate. Each grain of desert sand has taken an extraordinarily long time to reach its present form. It has been part of a mountain, then a boulder, then a rock, then a pebble, then a grain. The journey of a single grain of sand spans millions of years. There is no need to rush. Fact 14. Desert sand comes in many colors. The color depends entirely on what minerals make up the sand. The most common desert sand is white, or pale yellow, because it is mostly made of quartz, which is colorless. The orange and red sands that you see in deserts like the Namib, or in parts of Australia, get their color from iron oxide, which is rust. A very thin coating of iron oxide on each grain of sand gives it a warm, glowing orange or red hue. The beautiful orange dunes of Sossusvlei in Namibia, some of the highest sand dunes in the world, are the color of sunset because of this thin film of rust on every grain. In some places, dark volcanic sands create black deserts, and in others, white gypsum crystals create dazzling bright white dunes, like the White Sands National Park in New Mexico. Slowly, gently. Fact 15. White Sands National Park is a place of extraordinary, quiet beauty. The dunes there are not made of quartz sand at all. They are made of gypsum, a soft white mineral that is normally dissolved in water and washed away before it can accumulate. But in the Tularosa Basin in New Mexico, the rain that falls on the nearby mountains collects in a closed basin, meaning the water has nowhere to go, no river that leads to the sea, so it simply evaporates, leaving its gypsum behind. Over thousands of years, the gypsum has piled up into dunes of brilliant white, stretching across the land, like an enormous snowfield. Even in summer heat, it is one of the most unique places on Earth. A landscape created not by dryness alone, but by the particular geography of a valley that traps what little water it receives. Now, as we continue, Fact 16. Deserts can form for many different reasons, and scientists have identified several main types. There are subtropical deserts, like the Sahara, created by the sinking dry air at 30 degrees latitude. There are coastal deserts, like the Atacama and the Namib, created by cold ocean currents. There are rain shadow deserts, like the Gobi, created by mountains blocking moist air. And there are polar deserts, like Antarctica and the high Arctic, where the air is simply too cold to hold much moisture. Each type forms through a different combination of forces: latitude, ocean temperature, mountain height, and distance from the sea. But all of them share that single defining quality: very little water falling from the sky. And we can take a moment to notice. Fact 17. The Sahara Desert is often what people picture first when they think of deserts. It is the largest hot desert on Earth, covering about 9.2 million square kilometers across northern Africa. It stretches from the Atlantic Ocean in the west to the Red Sea in the east, a distance of about 4,800 kilometers. And from north to south, it spans about 1,800 kilometers. It is so vast that it is roughly the same size as the United States. But the Sahara has not always been a desert. There is evidence that just about 6,000 to 11,000 years ago, the Sahara was much greener. There were lakes, rivers, grasslands, and forests across much of the region. Prehistoric cave paintings found in the Sahara show images of hippos, crocodiles, cattle, and people fishing, creatures that require water to survive. There is no need to rush. Fact 18. The transformation of the Sahara from a green, watery landscape to a desert is one of the most dramatic climate changes in Earth's recent history. It happened because of a very slow, very gentle wobble in the way the Earth orbits the Sun. The Earth's axial tilt and the shape of its orbit change very slightly over thousands of years, in a cycle called the Milankovitch cycles, named after a Serbian mathematician. These tiny changes in Earth's orbit change how much sunlight different parts of the planet receive. In different seasons, about 6,000 years ago, the orbital changes shifted the monsoon rains that used to reach the Sahara slightly southward. Slowly, the rains retreated. Slowly, the lakes dried up. Slowly, the grasslands became scrub, and the scrub became sand, and the green Sahara disappeared. Quietly, over thousands of years. Slowly, gently. Fact 19. The idea that the Sahara breathes in and out, going from green to desert and back again, over cycles of thousands of years, is called the African Humid Period hypothesis. Scientists have found evidence of at least 5 or 6 such green periods in the Sahara's history, each separated by desert phases. The evidence comes from fossilized fish bones, ancient pollen trapped in lake sediment, and rock art deep in areas that are now completely barren. This tells us something comforting about the Earth. It is always changing, always slowly shifting, always moving through great, gentle cycles. What is dry today may be green again in thousands of years. What is green today may eventually dry. The planet is patient, beyond all imagining, and we can take a moment to notice. Fact 20. Even in the most apparently lifeless deserts, there is life. This is one of the most quietly wonderful things about deserts. Life finds a way, slowly, patiently, adapting over millions of years to conditions that seem impossibly harsh. In the Atacama, one of the driest places on Earth, scientists have found living microorganisms inside translucent rocks. The rocks let in just enough sunlight for tiny photosynthesizing bacteria to survive inside them, protected from the drying wind. These bacteria are doing something remarkable. They are living in one of the most inhospitable environments on our planet, inside a rock, surviving on the thinnest sliver of sunlight and the smallest possible amount of moisture. Life, it turns out, is extraordinarily persistent, gently moving forward. Fact 21. Desert plants have evolved some of the most interesting and beautiful survival strategies in the natural world. Take the cactus. Most people know that cacti store water in their thick, fleshy stems, but there is more to it than simple storage. The skin of a cactus is covered in a thick, waxy coating that reduces evaporation to almost nothing. Their spines, which are actually modified leaves, shade the surface of the cactus from the sun, reducing heat. The roots of cacti spread out wide and shallow, just below the surface of the soil, ready to absorb even the smallest amount of rain. Before it evaporates, some cacti can absorb enough water during a single rainstorm to survive for a year or more. The saguaro cactus of the Sonoran Desert can absorb and store over a ton of water after a single heavy rain. There is no need to rush. Fact 22. The saguaro cactus is one of the most iconic and slowest growing plants in the world. A saguaro does not even begin to grow its first arm, that characteristic branching shape, until it is about 75 years old. At 10 years of age, a saguaro might be only a few centimeters tall. A full-grown saguaro, with several arms, might be 150 to 200 years old. The largest saguaros can reach about 12 meters in height and weigh as much as a small car, most of that weight being stored water. They live in only a small part of the world, the Sonoran Desert, which spans southern Arizona in the United States, and the northwestern part of the Mexican state of Sonora. Their slowness, their patience, their great age, makes them feel like quiet, ancient sentinels of the desert. Slowly, gently. Fact 23. Many desert plants have very small leaves, or no leaves at all. This is because leaves are where plants lose most of their water, through a process called transpiration. Transpiration is when water moves up through a plant, from its roots, and evaporates from tiny pores in its leaves. In a wet environment, this is fine, but in a desert, losing water this way is very costly. So many desert plants have evolved very small leaves to reduce the surface area from which water can escape. Some, like cacti, have dispensed with leaves altogether and moved all their photosynthesis into their green stems. Others, like the ocotillo plant, have leaves that sprout only during the brief rainy season and then fall off to conserve water during the long dry months. And we can take a moment to notice. Fact 24. Some desert plants take water conservation to remarkable extremes. The welwitschia plant of the Namib Desert is one of the strangest plants in the world. It lives for extraordinarily long periods. Some specimens are believed to be over 1,500 years old, and carbon dating has confirmed ages of over 1,000 years. For some individuals, a welwitschia has only 2 leaves, which grow continuously from the base, throughout its long life, becoming shredded and ragged over the centuries. These 2 leaves are extraordinarily efficient at capturing moisture from coastal fog, which rolls in from the cold Atlantic Ocean. The fog is one of the Namib's few reliable water sources, and the welwitschia has spent millions of years evolving. To make the most of it, there is no need to rush. Fact 25. The fog of the Namib Desert is a remarkable natural phenomenon because the cold Benguela current keeps the ocean water near the coast very cold. Warm inland air that moves toward the coast is cooled rapidly when it meets the ocean air, and its moisture condenses into fog. This fog drifts inland, sometimes 50 kilometers or more. In the early mornings, for many desert creatures, this fog is their only source of water. The fog-basking beetle of the Namib has evolved a remarkable strategy. It crawls to the top of a sand dune in the early morning, faces into the wind, and tilts its body at just the right angle. Its back has tiny bumps on it that collect fog droplets. The droplets run down into grooves and flow directly into the beetle's mouth. It is an elegant, Quiet piece of evolutionary engineering. Let's take a quiet moment to think about. Fact 26. The desert at night is a completely different world from the desert in the day. Many desert animals are nocturnal, meaning they sleep during the hot hours of the day and come out at night when it is cooler. The temperature difference between day and night in a desert can be enormous. In some deserts, the daytime temperature might be 40 degrees Celsius or more, while the nighttime temperature might drop close to zero. This dramatic swing happens because dry air holds heat very poorly. In a humid place, moisture in the air acts like a blanket, trapping the warmth of the day through the night. But in a desert, there is no such blanket. As soon as the sun sets, the heat radiates away into the clear sky, and the temperature plunges. Clear desert nights are often extraordinarily cold, slowly, gently. Fact 27. Those clear desert nights create some of the best stargazing in the world. Because the air is dry air carries very little water vapor. And because deserts are often far from city lights, the sky above a desert at night is exceptionally clear and dark. You can see the Milky Way in its full glory from many desert locations. The Atacama Desert is home to some of the world's most powerful telescopes. For this very reason, its extraordinarily dry, clear atmosphere lets astronomers see deep into space with almost no atmospheric distortion or moisture to interfere. From the Atacama's high-altitude plateaus, scientists can observe the universe with remarkable clarity in a place defined by its absence of water. The absence itself becomes an extraordinary scientific tool, and we can take a moment to notice. Fact 28. Desert animals have evolved fascinating ways to deal with heat. One of the most important strategies is something called countercurrent heat exchange. In some desert animals, the blood flowing toward the brain and extremities passes very close to blood flowing back. From those areas, the warm blood going out transfers some of its heat to the cooler blood coming back, so that the core of the body stays cooler and the extremities stay warmer. This prevents the brain and vital organs from overheating. It is a beautifully simple and elegant piece of biological engineering. The animal is essentially recycling its own heat, keeping things balanced without spending extra energy. Many desert mammals, birds, and reptiles use variations of this technique. There is no need to rush. Fact 29. The fennec fox is one of the most charming and perfectly adapted desert animals in the world. It lives in the Sahara and Arabian deserts, and it has enormous ears, the largest ears relative to body size of any member of the dog family. These ears serve two purposes. First, they are extraordinary at detecting sounds, which helps the fennec fox hunt insects, small rodents, and lizards at night in near total darkness. Second, and perhaps more interestingly, the ears act as radiators. They are richly supplied with blood vessels near the surface of the thin skin, and heat from the blood radiates outward from these large surfaces into the cool night air. The ears help the fennec fox shed excess body heat quietly and efficiently without sweating or panting, slowly, gently. Fact 30. Camels are perhaps the most famous desert animals, and they are worth thinking about carefully because many of the things that people believe about camels are not quite right. The most common misconception is that camels store water in their humps. They do not. Their humps store fat, a dense reserve of energy that the camel can metabolize when food is scarce. However, camels are remarkable at conserving water. They can tolerate losing up to 30% of their body water before becoming seriously ill, a loss that would be fatal. For most mammals, they can drink enormous amounts of water very quickly when it is available, up to 200 liters in a single drinking session. Their kidneys produce very concentrated urine, and their bodies can allow their internal temperature to fluctuate widely without ill effect. Now, as we continue, Fact 31. Camels can also close their nostrils to a narrow slit, which reduces the amount of moisture lost. When they breathe in dry desert air, their long eyelashes and ear hair form barriers against wind-blown sand. Their wide, padded feet spread their weight across soft sand. Without sinking, even their red blood cells are unusual. Instead of the round, disc-shaped red blood cells that most mammals have, camel red blood cells are oval. This allows their blood to keep flowing, even when it becomes very thick and concentrated from dehydration, when the blood of other animals would become too viscous to circulate properly. Everything about the camel's body has been gently, patiently shaped by millions of years of desert life into something beautifully suited to its environment, and we can take a moment to notice. Fact 32. The dromedary camel, the one-hump species, most commonly associated with the Sahara and Arabian deserts, was domesticated by humans. Around 4,000 years ago, it became one of the most important animals in the history of human civilization, enabling trade routes across vast desert regions that would otherwise have been impassable. The famous Silk Road, the ancient network of trade routes connecting China to the Mediterranean, could not have functioned without camels. Spices, silk, glass, and ideas moved along those routes on camelback, connecting civilizations that might otherwise have remained entirely separate from one another. The great deserts of the world, rather than being barriers to human activity, became highways, slow, gentle highways, measured in days and weeks of walking. There is no need to rush. Fact 33. Speaking of ancient trade routes, the Oasis has been one of the most important geographical features in human history. An oasis is a fertile area in a desert where water reaches the surface or lies close enough below it to support plant life. Oases form where underground aquifers, those great, slow reservoirs of groundwater, intersect with the desert surface, often near faults in the rock or at the base of hills. The water in many desert aquifers fell as rain thousands or even tens of thousands of years ago during wetter periods and has been slowly seeping through rock. Ever since, it is ancient water, patient water, water that has been traveling underground since before the pyramids were built, slowly, gently. Fact 34. The aquifers beneath desert regions represent some of the largest stores of fresh water on Earth. The Nubian sandstone aquifer system, which lies beneath parts of Egypt, Libya, Sudan, and Chad, contains an estimated 150,000 cubic kilometers of water. That is an almost incomprehensible amount. It accumulated during the wetter periods of the Sahara's history, when rainfall soaked into the ground and slowly percolated down through porous sandstone rock. This water has been underground for perhaps 1 million years or more. In some places, this ancient water is being pumped to the surface for agriculture and drinking, but it is being used much faster than it can be replenished. It is, in a very real sense, a finite treasure left over from a greener time, and we can take a moment to notice. Fact 35. Desert soil is remarkable in its own quiet way. Unlike the rich, dark, life-filled soil of a forest or grassland, desert soil is pale and thin, and at first glance, almost empty, but it contains something extraordinary, a biological soil crust. This crust is a living community of microscopic organisms, cyanobacteria, mosses, lichens, algae, and fungi that forms a thin layer on the surface of the soil. This crust holds the soil together, preventing it from blowing away. In the wind, it captures moisture. It fixes nitrogen from the air, enriching the soil. For larger plants, it is fragile. A single footstep can destroy decades of growth, but it is vital. In many deserts, the biological soil crust is the invisible foundation of the entire ecosystem. There is no need to rush. Fact 36. One of the most extraordinary events in the desert is the desert bloom. In certain deserts, with rare but reliable rainfall, seeds can lie dormant in the soil for years, sometimes decades, waiting. When rain finally falls, these seeds germinate all at once. Within days of a rainstorm, a desert that has looked completely barren can be carpeted in flowers. The Atacama Desert, one of the driest places on Earth, experiences this phenomenon in occasional years when the El Niño weather pattern brings unusual rainfall. The desert, which normally looks like a lunar landscape, suddenly blooms, with over 200 species of flowers, transforming into a carpet of color. Scientists call this event a flowering desert, or desierto florido, and it is, by any measure, one of the most quietly miraculous sights in the natural world. Slowly, gently. Fact 37. The seeds that wait patiently in desert soil for years between rains are called xerophytic seeds. They have evolved special protective coatings that prevent them from germinating during small or insufficient rainfalls. Only a proper soaking, a real and sufficient rain, will trigger them to sprout. Some desert seeds contain chemical inhibitors that must be washed away by a threshold amount of water before germination can begin. This is a beautiful piece of evolutionary wisdom. If the seeds sprouted after every tiny shower, it might begin to grow and then die when the moisture quickly evaporated. By waiting for a real, substantial rain, the seed gives itself the best possible chance of surviving long enough to flower and set its own seeds. Patience in the desert is survival, and we can take a moment to notice. Fact 38. The temperature of desert sand can be astonishing. The surface of sand in the Sahara, on a hot summer afternoon, can reach 80 degrees Celsius, hot enough to fry an egg. This is much hotter than the air temperature, which might be 40 or 45 degrees. The reason is that sand has a very low capacity to hold heat, and it absorbs the full intensity of the sun's radiation and converts almost all of it to heat. At the surface, just a few centimeters below the surface, however, the sand is dramatically cooler. Many desert animals exploit this temperature gradient. They burrow just below the surface to escape the surface heat, while remaining shallow enough to emerge quickly. When night falls, the temperature difference between the surface and even 10 centimeters down can be 20 degrees or more. There is no need to rush. Fact 39. Desert varnish is one of the quietest and most mysterious features of desert landscapes. It is the dark, shiny coating that covers the surfaces of rocks. In many desert regions, a smooth, dark layer of manganese and iron oxides, often giving rocks a beautiful chocolate or reddish-black sheen. Rock varnish forms extremely slowly, over thousands of years, deposited by microorganisms, bacteria, that pull manganese and iron from dust and bind them to the rock surface. The process is so slow that the thickness of rock varnish can be used to estimate the age of rock surfaces. Ancient desert rock varnish is sometimes covered with petroglyphs, rock art carved by people thousands of years ago. The varnish has slowly grown back over the carved lines, helping scientists estimate how old the carvings are. Slowly, gently. Fact 40. Rock art in deserts is one of the most evocative links between the present and the ancient past. In the Sahara, in the Arabian Peninsula, in the American Southwest, and in the Australian Outback, there are thousands of sites where ancient people left images carved or painted on rock surfaces. Some of this rock art is over 10,000 years old. It shows animals, human figures, hands, geometric patterns, glimpses into the minds of people who who lived in these landscapes when they were very different places. In the Sahara, as we mentioned, paintings show hippos and cattle and people in boats. These images tell us that the desert was once inhabited by farmers and herders, people who lived comfortable lives in a place that is now one of the most inhospitable on Earth. Now, as we continue, Fact 41. The wind in a desert is a force of extraordinary, patient power. Over millions of years, desert winds carve rock into extraordinary shapes. Arches, spires, mushroom-shaped formations, great flat-topped mesas, and deep canyons. All of these are created by the slow, continuous work of wind, carrying sand and dust. The process is called aeolian erosion. After Aeolus, the Greek god of the winds, each grain of sand, carried by the wind, acts like a tiny piece of sandpaper against the rock it strikes. Over millions of repetitions, this carves and smooths and sculpts the rock into the shapes we see. The great sandstone formations of the American Southwest, Arches National Park, Bryce Canyon, Monument Valley, are all partly the work of wind and water over enormous stretches of time. And we can take a moment to notice. Fact 42. Dust storms in the desert can be enormous. A haboob is a type of desert dust storm that forms when a thunderstorm's downdraft hits the desert floor and picks up loose sand and dust, carrying it forward in a great wall that can be several kilometers high and hundreds of kilometers wide. Haboobs are most common in the Sahara, the Arabian Desert, and the Sudan region, where the Arabic word haboob originates, meaning blasting or drafty. When a haboob approaches, it looks like a solid wall of red or brown cloud rolling toward you. It is not dangerous in the way a tornado or hurricane is dangerous, but it can reduce visibility to near zero and deposit thick layers of dust over everything in its path. The silence afterward, the thick, dusty silence, is profound. There is no need to rush. Fact 43. Desert dust travels astonishing distances. Every year, millions of tons of dust from the Sahara Desert are lifted high into the atmosphere and carried across the Atlantic Ocean to South America. This Saharan dust is rich in phosphorus, a nutrient that is in short supply in the soils of the Amazon rainforest. Scientists have discovered that the Amazon's extraordinary fertility is partly maintained by this supply of nutrients blown in from a desert thousands of kilometers away. The desert feeds the rainforest, the two most extreme landscapes on Earth. The driest and the wettest are connected by invisible threads of dust floating high in the atmosphere. In nature, everything is connected to everything else in slow and quiet and beautiful ways, slowly, gently. Fact 44. The Arabian Desert covers most of the Arabian Peninsula, Saudi Arabia, Yemen, Oman, the United Arab Emirates, Jordan, Iraq, and Kuwait. It is the largest continuous sand desert in the world. Within the Arabian Desert lies the Rub al-Khali, or Empty Quarter, the largest continuous sand desert on Earth. It covers about 650,000 square kilometers, roughly the size of France. The dunes in the Rub al-Khali are some of the largest in the world, reaching heights of up to 250 meters. In this vast sea of sand, the silence is said to be absolute. The light is golden. The sky is immense. For the Bedouin people who have lived in and around this desert for thousands of years, it is a sacred landscape, profound in its emptiness, and we can take a moment to notice. Fact 45. The Gobi Desert spans parts of northern China and southern Mongolia. It is the world's fifth largest desert, covering about 1.3 million square kilometers. Unlike many of the deserts we have discussed, the Gobi is a cold desert. Winter temperatures can fall to -40 degrees Celsius, and snowstorms are not uncommon. The Gobi is in the rain shadow of the Himalayas and the Tibetan Plateau, which block the moist air of the Indian monsoon. Despite its harsh conditions, the Gobi has been a remarkably important region for paleontology, the study of ancient life. Some of the most extraordinary dinosaur fossils ever found, including complete nests of dinosaur eggs, have been discovered in the Gobi. The ancient bones are preserved in the dry, stable desert sediment, waiting patiently to be found. There is no need to rush. Fact 46. The discovery of dinosaur eggs in the Gobi Desert by the American explorer Roy Chapman Andrews in the 1920s was one of the most significant paleontological finds in history. Andrews and his team found nests of fossilized eggs belonging to an oviraptorid dinosaur, which proved definitively that at least some dinosaurs laid eggs and tended their nests. Before this discovery, the reproductive behavior of dinosaurs was largely unknown. The Gobi was not always the cold, dry place it is today. 70 to 80 million years ago, when these dinosaurs lived, the region was a semi-arid plain with seasonal rivers and scrubby vegetation. The sand dunes that preserved their eggs so well were an accident of geology, a gift from the desert to the future. Slowly, gently. Fact 47. The Australian Outback is one of the most distinctive desert landscapes in the world. About 70% of the Australian continent is classified as arid or semi-arid. The famous red coloration of the Australian desert soil comes from iron oxide, rust, coating the quartz grains. Just as in Namibia, Uluru, the great sandstone monolith that rises from the flat red plains of Central Australia, is one of the most iconic geological formations on Earth. It is about 350 meters high, and most of its bulk lies underground. Uluru is sacred to the Anangu Aboriginal people, who have lived in this landscape for at least 30,000 years, making them one of the oldest continuous human cultures on Earth, living in one of the oldest desert landscapes. And we can take a moment to notice. Fact 48. The Sonoran Desert of North America is the hottest desert in the United States and Mexico, and it is also one of the most biologically diverse deserts in the world. Unlike many deserts that receive most of their rain in a single short season, the Sonoran receives 2 rainy seasons, one in winter and one in summer, which allows a much greater variety of plants and animals to survive. The saguaro cactus forest is perhaps the most distinctive feature of the Sonoran, but there are also many other extraordinary organisms. The Gila woodpecker, which nests inside living saguaro cacti, the roadrunner, a bird that prefers running to flying, the Gila monster, one of the few venomous lizards in North America, and the palo verde tree, which photosynthesizes through its green bark because its leaves are so small. There is no need to rush. Fact 49. The Mojave Desert, also in North America, is famous for one of the most extraordinary plants in the desert world. The Joshua tree. The Joshua tree is not actually a tree. It is a member of the yucca family, and its closest relatives are lilies and agaves. It can live for hundreds of years, growing very slowly. The Joshua tree depends entirely on a single species of moth, the yucca moth, for its reproduction. The yucca moth is the only creature that pollinates Joshua tree flowers, and the moth lays its eggs inside the flowers so that its caterpillars can feed on some of the developing seeds. It is a relationship of mutual dependence so precise and complete that neither species can survive without the other. This kind of partnership, called mutualism, is one of the most beautiful patterns in the natural world. Slowly, gently. Fact 50. We have now talked about many of the world's great deserts and the different ways they formed. Let us take a gentle breath and simply appreciate the quietness of this for a moment. The deserts of the world exist because of an interplay of forces. The sun warming the equator, causing air to rise, that dry air drifting away and sinking at 30 degrees latitude, mountains blocking moist air from reaching inland regions, cold oceans cooling the air along certain coasts, the slow wobble of the Earth's orbit shifting rainfall patterns over thousands of years. All of these forces are gentle and slow and ancient. None of them are dramatic in human time. They operate over centuries and millennia, quietly, patiently, shaping the land in ways we can only understand by thinking about very long spans of time, gently moving forward. Fact 51. Water, when it does fall in the desert, is enormously powerful. Flash floods are one of the most significant forces shaping desert landscapes. When a heavy rainstorm hits a desert, which may happen only once or twice a year, the water cannot be absorbed quickly enough by the hard, dry, compacted soil, and it rushes over the surface in powerful torrents. These flash floods can carve deep gullies and canyons, move enormous boulders, and reshape entire valleys in a matter of hours. The Grand Canyon, that extraordinary chasm in Arizona, was carved largely by the Colorado River over millions of years. But the river itself was fed and shaped in part by the episodic floods of the desert region. Slow, patient geology, combined with sudden, powerful water, and we can take a moment to notice. Fact 52. Desert rivers, rivers that flow through desert regions, are called exotic rivers because their water comes from somewhere far away, somewhere with plentiful rain. The Nile is the most famous example. The Nile flows northward through the eastern Sahara, through thousands of kilometers of desert, and sustains one of the world's oldest and most remarkable civilizations along its banks. The water in the Nile comes from the highlands of Ethiopia and the lakes of East Africa, far to the south and east of the Sahara. The desert through which the Nile flows contributes almost nothing to its flow. The river is, in a sense, a visitor in the desert, a ribbon of green and life, cutting through the brown and still. There is no need to rush. Fact 53. The annual flooding of the Nile was, for thousands of years, the foundation of Egyptian agriculture and civilization. Each year, during the rainy season in Ethiopia, the Blue Nile and other tributaries swelled with water, and the flood reached Egypt in summer. The flooding deposited rich, dark silt, fine soil particles carried from the Ethiopian highlands, across the floodplain, renewing the fertility of the Egyptian farmland year after year. The ancient Egyptians called this fertile strip of land the Black Land, Kemet, after the color of the silt, and the surrounding desert was the Red Land, Dishret. Two worlds, side by side, the black, living, watery world of the river valley, and the red, silent, dry world of the desert. Slowly, gently. Fact 54. The word Sahara itself is believed to derive from the Arabic word for desert, Sahara, or possibly from the Berber language, where similar words mean barren. The Great Desert has been a defining feature of African geography for so long that it has shaped the very languages of the people who live near it. North Africa and Sub-Saharan Africa, the terms we use today, describe a continent divided by this enormous natural barrier. For most of human history, the Sahara made movement between North and South Africa very difficult. It was not impossible. Trade routes and nomadic paths crossed it, but it was slow and costly, requiring enormous preparation and skill. The desert shaped human history, in the same quiet, patient way it shapes rock, slowly, inexorably, over long spans of time. And we can take a moment to notice. Fact 55. The human experience of extreme heat in the desert is managed by the body in remarkable ways. When the air temperature rises above body temperature, about 37 degrees Celsius, the body can no longer lose heat to the air by simply radiating it away. The only remaining cooling mechanism is sweating. Sweat evaporates from the skin and carries heat away with it. In a dry desert environment, sweat evaporates almost instantly, which is very effective at cooling. A person in dry desert heat may not even feel very sweaty because the sweat evaporates so quickly. In humid heat, by contrast, the air is already full of moisture and cannot absorb much more, so sweat cannot evaporate efficiently, and you feel hot and damp. Dry desert heat counterintuitively, is easier for the body to cope with than humid heat. As long as you keep drinking water, there is no need to rush. Fact 56. The people who have lived in desert environments for centuries have developed extraordinary cultural knowledge about how to survive and thrive in the heat. The Tuareg people, who have inhabited the Sahara for thousands of years, wear long, loose, flowing robes that cover almost the entire body, including the face and hands. These robes trap a layer of cool air next to the skin, shading the body from direct sunlight, while allowing sweat to evaporate. The color of traditional Tuareg robes is often a deep indigo blue, a color that has come to be associated with the Sahara. The indigo dye is so embedded in Tuareg culture that it stains the skin over time, and Tuareg people are sometimes called the blue people of the desert. Slowly, gently. Fact 57. Architecture in desert climates has evolved over thousands of years to manage heat in clever and elegant ways. Traditional buildings in hot desert regions tend to have thick walls made of mud, brick, or stone. These thick walls have very high thermal mass. They absorb heat slowly during the day, keeping the interior cool, and release that heat slowly during the cool desert night, keeping the interior warm. This is a simple and beautiful way to use the natural properties of materials to moderate temperature without any energy input. Narrow streets in traditional desert cities shade each other from the sun. Central courtyards create shaded private outdoor spaces. Wind towers, tall hollow structures that catch the prevailing wind and channel it downward into buildings, provide natural air conditioning. And we can take a moment to notice. Fact 58. The ancient city of Sherbam in Yemen, sometimes called the Manhattan of the desert, demonstrates how brilliantly humans have adapted to desert life. Sherbam is a city of mud brick tower blocks, some of them 9 stories high, built in a defensive cluster in a desert valley. Many of these towers are over 500 years old. The mud brick from which they are built is an excellent thermal mass material, keeping interiors comfortable in both the heat of summer and the cold of winter nights. The towers are packed closely together to shade the narrow streets. The entire city is a masterpiece of desert-adapted architecture, built without any modern technology, using nothing but local materials, and accumulated generations of knowledge about how to live comfortably in a harsh environment. There is no need to rush. Fact 59. The phenomenon of mirages, those shimmering illusions of water that appear in the distance on hot desert roads, is a beautiful piece of atmospheric physics. A mirage occurs when a layer of very hot air near the ground causes light to bend. Hot air is less dense than cooler air above it, and light changes direction slightly when it passes from dense to less dense air. Light from the sky is bent upward from the layer of hot air near the ground and travels into your eye from a low angle. Your brain interprets this as light reflected from a water surface, because that is the most common situation in which you receive upward bent light at a low angle. There is no water, of course, just bent light, and a brain doing its best to make sense of the world, slowly, gently. Fact 60. Mirages are not hallucinations. They are real optical phenomena, and they can be photographed. What is being photographed, however, is not water. It is a distorted image of the sky. This is the key to understanding them. A mirage is a real image of something, just in the wrong place. The classic inferior mirage, the kind you see on hot roads and in deserts, shows a distorted, shimmering image of the sky below the horizon, which the brain reads as a reflective water surface. There is also a rarer type, called a superior mirage, which can make distant objects appear to float above the horizon, or even to appear in the sky, where they don't physically belong. Sailors and desert travelers have been seeing and describing these phenomena for thousands of years. Now, as we continue, fact 61. Thunder and lightning in the desert are infrequent, but when they occur, they are extraordinary. A desert thunderstorm is one of the most dramatic and beautiful natural spectacles, because the air is so clear and dry. You can often see lightning strikes from great distances, sometimes 60 or 80 kilometers away. The sound of distant thunder rolls across the flat, open landscape, without obstacle, and the smell of rain on hot desert rock, a scent called petrichor, is one of the most evocative and comforting smells. In the natural world, petrichor comes from an oil produced by plants and absorbed by soil, which is released when rain falls, mixing with another compound produced by soil bacteria, called geosmin. The result is that distinctive, beautiful smell that says, rain is coming, and we can take a moment to notice. Fact 62. The word petrichor was coined in 1964 by two Australian researchers, Isabel Joybert and Richard Grenfell Thomas, who were studying the source of that distinctive rain-on-dry earth smell. They published their findings in the journal Nature, and they combined the Greek words petra, meaning stone, and ichor, which in Greek mythology was the fluid that flowed in the veins of the gods. It is a lovely name for a lovely thing. Scientists have since identified the compounds responsible for petrichor and geosmin in great detail, but knowing the chemistry does not reduce the pleasure of the smell. If anything, it adds to it, knowing that you are smelling the products of soil bacteria and ancient plant oils, the smell of rain touching the earth. After a long absence, there is no need to rush. Fact 63. The desert is not silent. At night especially, deserts are alive with sound. The calls of owls, the scurrying of small rodents, the wind across the dunes, the occasional distant howl of a coyote or jackal. But there is one sound unique to deserts that has puzzled and enchanted travelers for centuries: the sound of singing sand. Some sand dunes produce a deep, resonant, musical humming sound, sometimes described as a low roar, a bass note, a sound like a distant cello or organ. When sand avalanches down their slopes, the sound can last for several minutes and can be heard from several kilometers away. Scientists now understand that this happens when sand grains, of exactly the right size and roundness, moving together, vibrate at the same frequency, and amplify each other's sound through the dune, slowly, gently. Fact 64. Singing sand dunes are found in about 35 locations around the world. The Dunhuang region of China has famous singing dunes, as does the Rub al-Khali in Arabia, and certain dunes in Morocco. The frequency of the sound, usually somewhere between 60 and 105 Hz, is determined by the size of the sand grains. Larger grains produce lower frequencies. Smaller grains produce higher ones. The same dune can produce the same note, year after year, because the grain size within it stays consistent. Ancient travelers, in the Arabian and Chinese deserts, sometimes attributed this sound to spirits or supernatural forces. It is instead a beautiful example of how simple physical principles, the vibration of uniform grains, moving in unison, can create something that sounds almost like music, and we can take a moment to notice. Fact 65. Desertification, the process by which previously non-desert land becomes desert, is a slow, quiet process that is accelerating in some parts of the world. It happens when land is overgrazed, when trees are removed, when soil is exposed to wind, and erodes, when water tables drop. Once vegetation cover is lost, there is nothing to shade the soil, and surface temperatures rise. The bare soil reflects more sunlight, changing the local climate. Less moisture is retained. Less rain falls locally. The process is self-reinforcing. Once it begins, it tends to continue. The Sahel region of Africa, a broad band of land at the southern edge of the Sahara, has experienced significant desertification. In the second half of the 20th century, driven by a combination of drought and human land use, there is no need to rush. Fact 66. However, there is also a reverse process. Desertification can sometimes be reversed by careful, patient work. The Great Green Wall is an ambitious African project to restore degraded land across the width of the continent, following the southern edge of the Sahara, from Senegal in the west to Djibouti in the east, a distance of about 8,000 kilometers. Communities in many countries are planting native trees, restoring degraded land, and changing agricultural practices. In parts of Niger, a traditional practice called farmer-managed natural regeneration, allowing and encouraging naturally sprouting trees to grow in fields rather than removing them, has transformed millions of hectares of degraded land into productive tree-covered landscape. In just a few decades, nature, given the chance, restores itself, slowly, gently. Fact 67. The Aral Sea in Central Asia offers one of the most striking examples of how human activity can create desert conditions. In a matter of decades, the Aral Sea was, until the 1960s, the fourth largest lake in the world. Beginning in the 1960s, Soviet engineers diverted the rivers that fed it, the Amu Darya and the Sir Darya, to irrigate cotton fields across the region. Without its rivers, the Aral Sea shrank rapidly. By the 1980s, it had lost half its volume. By the early 2000s, it had essentially split into small remnant lakes. The exposed former lakebed became a salt desert. The fishing villages, on its old shores, are now stranded in the middle of dry, salt-crusted land. It is a quiet and melancholy reminder of how quickly a landscape can change, and we can take a moment to notice. Fact 68. In the smaller northern portion of the former Aral Sea, there is a story of quiet hope. Kazakhstan built a dam, the Cockerel Dam, in 2005, which stopped water draining south and allowed the northern section of the sea to slowly refill. Within just a few years, water levels rose significantly. Fish returned. The salinity dropped. Local fishermen began to catch fish again. After decades of absence, the vegetation on the shores began to recover. It is a small recovery, and the larger southern sections remain dry. But it shows something important, that even heavily damaged landscapes can respond and begin to heal when given the right conditions. Recovery is slow, but it is real. There is no need to rush. Fact 69. The relationship between deserts and carbon is more complex and interesting than it might first appear. Deserts and arid lands store a significant amount of carbon in their soil, in biological crusts, and in their sparse vegetation. Some scientists have recently discovered that the world's dryland regions, which include deserts and semi-deserts, may actually be absorbing more carbon dioxide than was previously thought. The sparse vegetation in these regions responds strongly to increased rainfall years, growing more and absorbing more carbon. The enormous area of dryland on Earth means that even small changes in their carbon uptake can have significant effects on global carbon budgets. The desert, in its quiet, patient way, is part of the global breathing of carbon, slowly, gently. Fact 70. Mars is the most famous extraterrestrial desert we know of. Mars is covered in fine red dust, iron oxide, just like the red sands of the Australian Outback and the Namib, and it receives almost no precipitation. Its atmosphere is extremely thin, less than 1% of Earth's atmospheric pressure at the surface, and the surface temperature averages about minus 60 degrees Celsius. Mars is a cold, dry, rocky desert on a planetary scale. However, Mars has not always been desert. Evidence from orbiting spacecraft and rovers shows ancient riverbeds, dried lake basins, and mineralogy consistent with liquid water having once existed. On the surface, Mars, like the Sahara, was once wetter, and like the Sahara, it slowly dried, and we can take a moment to notice. Fact 71. The surface of Mars is covered in some of the most spectacular dust storm systems. In the solar system, Martian dust storms can grow to cover the entire planet. lasting for weeks or months. When NASA's Opportunity rover fell silent in 2018, it was because a global Martian dust storm covered its solar panels with dust, cutting off its power supply. The rover had been operating for nearly 15 years, far beyond its original 90-day mission. It had driven over 45 kilometers across the Martian surface, exploring impact craters and ancient rock formations in this cold red planetary desert. The last message received from Opportunity, before it went silent, was interpreted by engineers as, "My battery is low and it's getting dark." A quiet and gentle ending, and there is no need to rush. Fact 72. Back on Earth, the relationship between desert sand and music has a long history. The berimbau, a Brazilian musical instrument, uses a gourd resonator that was traditionally dried by leaving it in the hot sun. The kora, a West African harp lute, is traditionally strung with strings made from plant fibers, treated with dry desert air methods. But perhaps the most direct connection between desert and music comes from the tradition of desert blues, a style of music played by Tuareg musicians of the Sahara, sometimes called guitar of the desert. Tuareg musicians, particularly from Mali and Niger, play a style of electric guitar music, influenced by their nomadic desert culture, with hypnotic, repetitive rhythms that are said to reflect the long, quiet, rhythmic journey across the sand. Slowly, gently. Fact 73. The economy of evaporation is a concept worth sitting with for a moment. In a desert, water evaporates very quickly because the air is dry, and in hot deserts, the temperatures are high. The rate of evaporation in a desert is usually many times higher than the rate of precipitation. The Sahara, for instance, loses far more water to evaporation than it receives as rain. The potential evaporation, the amount that would evaporate if there were enough water present, might be hundreds or thousands of millimeters per year in a hot desert, compared to an actual rainfall of perhaps 25 millimeters. This enormous deficit is why deserts are so dry. It is not only that little rain falls, but that even what does fall disappears almost immediately back into the atmosphere, and we can take a moment to notice. Fact 74. Salt flats are one of the most strikingly beautiful features of desert landscapes. They form in desert basins, where lakes have evaporated, leaving their dissolved minerals behind as a solid layer of salt and other minerals. On the surface, the Bonneville Salt Flats in Utah and the Salar de Uyuni in Bolivia, the world's largest salt flat, covering about 10,000 square kilometers, are examples. The Salar de Uyuni is so flat and white that when covered with a thin film of water after rain, it becomes the world's largest natural mirror. The reflections of clouds and sky, stretching to the horizon in all directions, create an image that looks more like the surface of another planet than anywhere on Earth, a place of extraordinary, quiet beauty. There is no need to rush. Fact 75. The Salar de Uyuni also contains enormous deposits of lithium, a metal crucial for making batteries, used in electric vehicles and portable electronics. Bolivia holds an estimated 21 million tons of lithium reserves, which may be the largest deposit in the world. The lithium is dissolved in the brine that lies below the salt crust. This makes the Bolivian desert a region of extraordinary importance for the world's transition away from fossil fuels. The connection between this silent, otherworldly salt desert and the batteries in your phone or laptop is one of the many quiet, surprising ways that deserts are woven into modern life. Slowly, gently. Fact 76. Solar energy and deserts have a natural and beautiful relationship. The same qualities that make deserts inhospitable to many forms of life, intense sunlight, clear skies, very little cloud cover, make them ideal locations for solar power generation. The Sahara Desert alone receives enough solar energy every year that if a small fraction could be captured It could theoretically supply all of the world's current energy needs many times over. Several large solar power installations have been built in desert regions, and more are planned. The Noor Solar Complex in Morocco is one of the world's largest concentrated solar power plants. Located on the edge of the Sahara, the desert, which has been slowly receiving sunlight for millions of years, may one day be one of the world's great sources of clean energy. And we can take a moment to notice. Fact 77. The Thar Desert in South Asia, also called the Great Indian Desert, occupies parts of northwestern India and eastern Pakistan. It is the most densely populated desert in the world, home to about 83 people per square kilometer, compared to the Sahara's average of less than 1 person per square kilometer. The reason for this dense population is the monsoon. While the Thar meets the scientific definition of a desert, receiving under 250 millimeters of rain per year in its driest parts, it receives more rainfall than most deserts, and much of this falls in a single intense monsoon season. This brief but intense rain supports enough agriculture to sustain a significant population. The seasonal cycle of the Thar, dry, hot, and dusty for most of the year, then green and damp during the monsoon, gives it a rhythm all its own, and there is no need to rush. Fact 78. Many desert cultures have developed deep spiritual traditions connected to their landscapes. For the Navajo people of the American Southwest, the desert landscape, its mesas, canyons, and wide open skies, is sacred, alive with spiritual meaning, and the home of their ancestors. For Aboriginal Australians, the desert outback is crisscrossed with invisible songlines, paths of spiritual significance, along which ancestral beings walked in the dreaming, singing the world into existence. For the Bedouin, the desert is a place that teaches patience, self-reliance, and a profound awareness of the present moment. These traditions remind us that places we might initially consider harsh or empty are in fact rich with meaning for the people who know them, slowly, gently. Fact 79. The Dashti Kavir and Dashti Lut deserts in Iran are two of the world's great desert landscapes. The Dashti Lut, sometimes called the Lut Desert, is notable for having recorded the highest confirmed surface temperature on Earth, 70.7 degrees Celsius, measured not by a thermometer on the ground, but by a NASA satellite studying land surface temperatures from orbit. At this temperature, the ground is hot enough to bake bread. The Lut Desert gets this hot because it sits in a deep topographic depression, surrounded by mountains that block wind, and because its dark, salt-crusted surface absorbs solar radiation very effectively. But even here, in this apparently extreme and inhospitable landscape, life exists. Extremophile bacteria have been found surviving in the crust, and we can take a moment to notice. Fact 80. Extremophile organisms, forms of life that survive in extreme conditions, have taught scientists a great deal about the potential for life elsewhere in the universe. If life can survive in the Atacama, in the Lut Desert's baking surface crust, in the salt flats, and in Antarctic ice, then perhaps life is more common in the universe than we once thought. Astrobiologists, scientists who study the possibility of life beyond Earth, use desert environments as analogs for conditions on other planets. The dry valleys of Antarctica, for example, are considered one of the best analogs for the surface of Mars. Studying how life clings to these extreme places on Earth helps scientists design experiments to search for life on other worlds, and there is no need to rush. Fact 81. The physics of sand is surprisingly complex and has been a subject of serious scientific study. Sand is a granular material, a collection of solid particles that can flow, somewhat like a liquid, but also support weight, like a solid, depending on conditions. A pile of sand can behave like a solid, supporting a person's weight, or like a liquid, flowing away underfoot. Quicksand is a real phenomenon that occurs when saturated sand is shaken or vibrated, the water and sand separate, with water rising to the surface and the solid particles losing contact with each other. The result is a material that cannot support weight. True quicksand is rarely as dangerous as portrayed in films. You will not simply sink and disappear, but it can trap a person effectively. There is no need to rush. Fact 82. The angle of repose is a fundamental concept. In desert sand physics, when you pour dry sand, it forms a cone. The steepness of that cone, the angle at which sand will rest stably, without avalanching, is called the angle of repose. And for typical dry sand, it is about 33 to 34 degrees. If you add more sand, and the slope exceeds this angle, the sand will slide down until the slope returns to 33 degrees. This is why sand dunes have a characteristic shape. The windward side is gentle and gradual, but the lee side, the side away from the wind, always sits at close to the angle of repose. Grains blown to the top by the wind avalanche down the lee face and come to rest at 33 degrees. Simple physics, repeated billions of times, creates the graceful, predictable shape of a dune, slowly, gently. Fact 83. Wind erosion in deserts creates remarkable benefact stones, rocks shaped by the sandblasting action of wind-carried sand, because sand bounces close to the ground rather than being carried very high. The erosive effect is strongest near the surface. This means that a rock sitting on the desert floor may be heavily carved and faceted near its base, while its top remains relatively unaffected. Some benefacts develop multiple flat facets, like a gem, if the prevailing wind direction changes over time. The study of benefacts can tell geologists about ancient wind patterns, which way the wind blew, and how strongly, thousands or millions of years ago, rocks become books, written in the language of ancient wind. And we can take a moment to notice. Fact 84. Desert pavement is another quiet wonder of the desert world. In many rocky deserts, the ground is covered in a flat, closely packed layer of small stones, as if someone has carefully laid a mosaic tile floor across the landscape. This pavement forms over thousands of years as wind removes the fine particles, sand and silt, from the surface, leaving only the larger pieces of gravel and stone behind. Some researchers have also suggested that stones gradually rise to the surface from below through the expansion and contraction of soil, from temperature changes, and from wetting and drying. Whatever the exact mechanism, the result is a stable, flat surface of interlocking stones, beneath which the fine-grained soil is protected from further wind erosion. There is no need to rush. Fact 85. Inselbergs are isolated hills or mountains that rise abruptly from flat desert plains. The name is German for island mountains. They form when softer surrounding rock is eroded away over millions of years, leaving behind a hard, resistant core of rock standing above the plain. Uluru is perhaps the most famous Inselberg in the world, but they are found in many desert regions, particularly in Africa. The great domed granite Inselbergs of the Namib and the Sahel, called Bornhards, are some of the most dramatic landscapes on Earth. Smooth, rounded domes of gray rock rising from flat red plains, with almost no vegetation. On their swept, polished surfaces, they look like the backs of enormous sleeping animals, half buried in the desert floor, slowly, gently. Fact 86. The question of why some desert rocks are rounded and dome-shaped, while others are jagged and angular is answered by a process called exfoliation or onion skin weathering. Granite and similar rock types are formed under great pressure, deep underground, when the rock is gradually exposed at the surface by erosion of the rock above it. The pressure is released and the rock expands slightly. This creates cracks parallel to the surface, which peel off like layers of an onion, over time, rounding off any sharp edges and corners. The corners and edges of a rock lose material faster than the flat faces because they are exposed to weathering from multiple directions. Over millions of years, an angular block becomes a smooth, rounded dome, and we can take a moment to notice. Fact 87. Water under the desert can sometimes burst upward under its own pressure to create a natural artesian well. An artesian well occurs when groundwater is trapped in a porous rock layer called an aquifer between two impermeable layers and is under pressure because the aquifer is tilted. If a well is drilled into this pressurized aquifer, the water rises on its own, sometimes even spouting above the surface. Artesian wells have been crucial to human settlement in desert regions. The Great Artesian Basin of Australia, one of the largest and deepest freshwater aquifer systems in the world, has supplied water to the dry interior of Australia for over a century through artesian wells, making pastoral farming possible across regions that would otherwise have been entirely waterless. There is no need to rush. Fact 88. Desert lakes, called playas, when they are dry, or bolsones, in some regions, are flat, dry lake beds that fill with water temporarily after rain and then dry again as the water evaporates. The surface of a dry playa is often cracked into a network of polygonal shapes, those familiar hexagonal or pentagonal patterns. In dry mud, these cracks form when wet clay mud dries and shrinks, pulling apart in a characteristic pattern that minimizes internal stress, much like how a glaze on a ceramic pot develops fine crackle patterns. As it dries, the hexagonal cracking pattern is found wherever wet clay dries, in a playa, on the bottom of a pond, in dried paint, on the surface of a drying lake. It is one of nature's most universal and repeating patterns, slowly, gently. Fact 89. The Dead Sea, while not a desert itself, demonstrates the extreme end of what happens to water in arid conditions. The Dead Sea is a salt lake bordered by Jordan to the east and Israel and the West Bank to the west. It sits in the Jordan Rift Valley, the lowest land surface on Earth, at about 430 meters below sea level. It has no outlet. The water that flows in from the Jordan River has no way to escape, except by evaporating, so all the minerals dissolved in the water concentrate. Over time, the Dead Sea is about 10 times salter than the ocean. Nothing can survive in it except certain salt-tolerant microorganisms. The water itself is a strange, heavy, almost oily consistency, and it turns the shoreline white with crystallized salt, and we can take a moment to notice. Fact 90. The Dead Sea is slowly shrinking because the Jordan River, its only significant inflow, has been heavily diverted for irrigation in the surrounding countries. Far less water reaches the Dead Sea than it once did. The sea level has been dropping at a rate of about 1 meter per year. As it shrinks, the exposed former lakebed develops sinkholes. The salt and gypsum left by the evaporating water dissolves when fresh water from underground springs reaches it, creating cavities that can suddenly collapse. Thousands of sinkholes have formed along the former shoreline. It is a slow, quiet, visually striking process, a landscape literally dissolving into itself, creating an increasingly strange terrain of salt formations, pools, and sudden holes. There is no need to rush. Fact 91. Deserts at high altitude are called montane deserts or cold deserts, and they combine the characteristics of both desert and mountain environments. The Tibetan Plateau, sometimes called the roof of the world, is the world's highest and largest plateau, with an average elevation of over 4,500 meters. It is also a cold desert. The plateau is sheltered from the Indian monsoon by the Himalayas, and its high altitude means the air is thin and holds little moisture. Winter temperatures can fall to -40 degrees Celsius. Yet the Tibetan Plateau is home to remarkable wildlife. The snow leopard, the Tibetan antelope, wild yak, all adapted to cold, dry, high-altitude life. It is one of the most extreme inhabited environments on Earth, a high desert swept by cold winds, under a sky that feels closer to space, slowly, gently. Fact 92. The Tibetan Plateau has an interesting effect on the entire Asian climate. It is so large and so high that it acts almost like a second ground surface for the atmosphere. At altitude, in summer, the plateau heats up, creating a region of low pressure that pulls moist air northward from the Indian Ocean, driving the South Asian monsoon. In winter, the plateau radiates heat rapidly and creates a region of high pressure that pushes dry, cold air southward. The Tibetan Plateau is, in other words, one of the most important drivers of the Asian monsoon system, one of the most important climate features on Earth, a great high desert that does not merely respond to the climate, but actually helps create it. And we can take a moment to notice. Fact 93. Some of the most beautiful geological formations in the world are found in desert environments. The Wave, in Arizona, is a sandstone rock formation whose surface has been sculpted by wind and water into extraordinary, smooth, undulating, striated curves of red, pink, and cream. It looks like a frozen wave of stone or a painting by a surrealist artist. It was formed about 190 million years ago from ancient sand dunes that were buried, compressed, and cemented into sandstone, then slowly carved over millions of years. The different colors come from layers of iron-rich minerals deposited at different times. The wave is so fragile that only 20 visitors are allowed per day, and their footsteps must follow a careful path to avoid damaging the surface. There is no need to rush. Fact 94. The formation of the wave reminds us that the sandstone cliffs and formations of many desert regions are, in a very literal sense, ancient fossilized sand dunes. The layers you can see in the walls of the Grand Canyon, in the cliffs of Zion National Park, and in the formations of the American Southwest were once sand blown into dunes by ancient winds in ancient deserts. These ancient Aeolian deposits, called Aeolianites, when they are lithified or turned to stone, preserve a record of ancient climates, ancient wind directions, and ancient desert conditions. A geologist reading these layers is reading a history of wind and sand going back hundreds of millions of years. Slowly, gently. Fact 95. Lichens are among the most extraordinary life forms found in deserts. A lichen is not a single organism, but a partnership, a symbiosis, between a fungus and either an alga or a cyanobacterium. The fungus provides structure and protection. The alga, or cyanobacterium, provides food through photosynthesis. Together, they can survive conditions that neither could survive alone. Lichens are found on rocks in some of the most extreme desert environments on Earth. They grow extremely slowly, sometimes less than 1 millimeter per year, and they can be very old. Some Arctic and alpine lichens are estimated to be over 8,000 years old, making them among the oldest living things on Earth. A small circle of gray-green crust on a desert rock, no bigger than a coin, may have been growing since before the pyramids were built, and we can take a moment to notice. Fact 96. The Kalahari Desert in southern Africa is what geographers call a fossil desert or semi-desert. It receives somewhat more rainfall than a true desert, between 150 and 500 millimeters per year in most areas, but its sands and sparse vegetation give it the appearance of a desert landscape. The Kalahari was a much drier, more extensive, true desert during the last ice age, when global conditions were very different. Today, it supports significant wildlife: lions, leopards, cheetahs, brown hyenas, giraffes, and the remarkable San people, hunter-gatherers, who have lived in this landscape for perhaps 100,000 years, the oldest continuous human culture in the world. The San possess extraordinarily detailed ecological knowledge about every plant and animal in their landscape. There is no need to rush. Fact 97. The San people's knowledge of desert survival is both practical and profound. They know which plants can be squeezed for water during dry seasons, which roots hold moisture underground, which animals' footprints reveal where water is nearby. They can follow a set of animal tracks across sandy ground and deduce not only the species, but the individual animal's condition, speed, and how long ago it passed. This knowledge, accumulated over countless generations, represents a form of science, careful, empirical, systematic observation of the natural world, just expressed differently. From Western academic science, many of the most important medical plants and ecological insights from desert environments have come from indigenous peoples who have been carefully observing their world for thousands of years, slowly, gently. Fact 98. The desert tortoise of the Mojave and Sonoran deserts is a remarkably patient creature. It spends about 95% of its life underground, in burrows, avoiding the extremes of both summer heat and winter cold. When it does emerge, it moves slowly and deliberately. A desert tortoise can live for 80 to 100 years, possibly longer. It stores water in its bladder, a reserve that can sustain it through long dry periods. If you pick up a frightened desert tortoise, it may release this stored water as a defense, and it may then not be able to replace that water before the next rain, with potentially serious consequences. The desert tortoise is a creature shaped by millions of years of patience, moving slowly through an ancient landscape with great, unhurried purpose, and we can take a moment to notice. Fact 99. Many desert mammals are specialist burrowers. Burrowing reduces exposure to temperature extremes, provides protection from predators, and in some environments, can allow access to underground moisture. The meerkat of the Kalahari, the banded mongoose, the desert ground squirrel, all rely on burrow systems. The kangaroo rat of North American deserts is so perfectly adapted to burrowing and desert life that it never needs to drink water at all. It extracts all the water it needs from the dry seeds it eats through metabolic processes that convert the hydrogen in organic molecules into water. It is metabolic water, water made by the body from food rather than drinking water. Its kidneys are extraordinarily efficient, producing very concentrated urine. To conserve every molecule, there is no need to rush. Fact 100. We have reached our 100th fact together, and we can take a very gentle, very quiet moment to notice how far we have traveled. We have moved from the simple question of why deserts exist, the gentle physics of rising and sinking air, of mountains and ocean currents, out through the Sahara and the Atacama, the Gobi and the Namib, the Arabian sands and the Australian Outback. We have met cacti and camels, fennec foxes and kangaroo rats, welwitschia plants and fog-basking beetles. We have thought about the physics of sand and the optics of mirages, about ancient rock art and salt flats and artesian wells, and there is still more to discover. Gently, quietly, one thought at a time, gently moving forward. Fact 101. The Patagonian Desert in South America is the largest desert in South America and the 8th largest in the world. It covers most of the southern part of Argentina, a cold, windswept plateau of steppe and shrub. The Patagonian Desert is in the rain shadow of the Andes Mountains, which block moist Pacific air from reaching the plateau. The winds that blow across Patagonia are legendary for their strength. Sailors have called the latitudes of the southern hemisphere, where Patagonia sits, the roaring 40s, furious 50s, and screaming 60s. These winds drive across the landscape with almost nothing to obstruct them. No forests, no hills. The scrubby vegetation bends permanently in the direction of the prevailing wind, and every rock and stone is smoothed on its windward face, slowly, gently. Fact 102. The Chihuahuan Desert, shared between the United States and Mexico, is the largest desert in North America. It covers about 360,000 square kilometers and sits at elevations between 1,000 and 1,500 meters above sea level. Because of its altitude, it is cooler than lower elevation deserts. It receives most of its rain in summer during the monsoon season, and this summer rainfall supports a remarkable diversity of plants, over 3,500 species of vascular plants, making it one of the most biologically diverse desert regions in the world. It is home to the Chihuahuan Desert agave, from which mezcal is made, to black-tailed prairie dogs, to the Mexican spotted owl, and to the extraordinary cave system of Lechuguilla Cave, whose unique mineral formations have been shaped over millions of years by sulfuric acid in the groundwater, and we can take a moment to notice. Fact 103. The growth of cities in desert environments is one of the most striking examples of human ingenuity and, at the same time, one of the most complex environmental challenges of the modern era. Las Vegas, in the Mojave Desert of Nevada, sits in a landscape that receives less than 100 millimeters of rain per year. It has a metropolitan population of over 2 million people. Phoenix, Arizona, in the Sonoran Desert, has a metropolitan population of nearly 5 million. The water for these cities comes from the Colorado River, which is already so heavily diverted that it barely reaches the sea. As the climate warms and the population grows, The question of how much longer the Colorado River can supply enough water for the desert cities and farms of the American Southwest is one that scientists and policymakers think about very carefully. There is no need to rush. Fact 104. Dubai and Abu Dhabi in the United Arab Emirates represent perhaps the most extreme example of desert city building, built almost entirely on desert land. In the 20th century, these cities have been created from almost nothing. In the space of a few decades, their water comes primarily from desalination, the removal of salt from seawater, powered by fossil fuels. Desalination is energy intensive, but it turns the limitless resource of seawater into fresh water, making life in the desert possible. Regardless of rainfall, the United Arab Emirates is one of the world's leaders in desalination technology. In a region where fresh water is perhaps the scarcest resource of all, desalination has made possible a level of urban development that would have been unimaginable a century ago. Slowly, gently. Fact 105. The biodiversity of desert soils is surprising to most people. A single teaspoon of desert soil can contain millions of microorganisms, bacteria, archaea, fungi, and microscopic animals. These organisms form complex communities that cycle nutrients, help plants absorb minerals, and decompose organic matter. Desert soils also host communities of nematode worms, microscopic roundworms, so small they are invisible to the naked eye, which prey on bacteria and fungi and are themselves preyed on by other microorganisms. These invisible communities are the foundation of all desert ecosystems, as fundamental to the desert as the visible sand and rock and sky. Most of them are not yet named or studied. The microscopic desert is almost entirely unexplored, and we can take a moment to notice. Fact 106. Desert plants communicate with each other and defend themselves using chemical signals. When a desert shrub is damaged by an insect, it releases volatile chemical compounds into the air. Nearby plants of the same species can detect these compounds and respond by increasing their own production of toxic or unpalatable chemicals in their leaves, making themselves less attractive to the insect. This chemical communication was first described in agricultural plants and trees, but it occurs in desert plants too. The creosote bush of the American Southwest, one of the most characteristic and adaptable of all desert plants, produces a chemical called nordohydroguaretic acid, which is strongly antifungal and antibacterial, and which gives the bush its distinctive sharp smell. The smell of the Mojave after rain. There is no need to rush. Fact 107. The creosote bush is remarkable in another way. It reproduces by cloning itself. A single plant, over thousands of years, can spread outward in a ring as the center of the original plant dies and new clones grow. From the roots around the perimeter, there is a creosote bush ring in the Mojave Desert, nicknamed King Clone, that is estimated to be approximately 11,700 years old, making it one of the oldest living organisms on Earth. It does not look like one organism. It looks like a ring of separate bushes, about 15 meters in diameter, but all the bushes in the ring are genetically identical, descended from a single seed that germinated when the Sahara was still green, when woolly mammoths still walked the earth, slowly, gently. Fact 108. rain in the desert has a quality of light that is unlike rain anywhere else, because desert air is normally so clear and dust-laden. When rain begins to fall from a desert thunderstorm, the combination of raindrops and dust in the air can create extraordinary optical effects. Deep amber light, intense rainbows, the air itself seeming to glow. Desert rainbows are often more vivid than rainbows in humid climates because the background against which they appear, the deep blue-black of a desert storm cloud against an otherwise clear sky, is more dramatic, and because rain in the desert is rare, it carries with it a sense of occasion, the smell of petrichor, the sound of thunder, the first drops raising small craters of dust. These things feel, in the desert, like a gift, and we can take a moment to notice. Fact 109. The Namib National Park in Namibia is one of the largest conservation areas in the world, covering over 49,000 square kilometers. It protects the extraordinary landscape of the Namib Desert, including the towering dunes of Sossusvlei, some of the highest dunes in the world, the ancient bleached trees of Deadvlei, and the fog belt coastline. Deadvlei is a white clay pan surrounded by enormous orange dunes dotted with the blackened, dead trunks of camel thorn trees that died about 900 years ago when the dunes cut off the watercourse that fed them. The dead trees have not rotted because the air is too dry. They stand in the white clay, black against the orange dunes, preserved by the desert air for nearly 1,000 years. It is one of the most photographed landscapes in the world. There is no need to rush. Fact 110. The Wadi Rum Desert in Jordan, sometimes called the Valley of the Moon, is a dramatic landscape of sandstone mountains and cliffs rising from a flat desert floor. The sandstone is ancient, some of it over 500 million years old. It has been carved by wind and occasional floods into arches, canyons, and soaring vertical faces. The valley has been inhabited by humans for thousands of years. The Nabatean civilization, which also built the famous rock-cut city of Petra, left inscriptions and carvings on the cliff faces. Wadi Rum has a remarkable quality of silence and stillness. It has been described by T. Lawrence, the British officer who lived and fought here during World War I, as vast, echoing, and godlike. More recently, it has served as a filming location for Mars in several science fiction films because its landscape of red rock and flat sand so closely resembles what we imagine the Martian surface to look like. Slowly, gently. Fact 111. The deserts of the Badlands in South Dakota are not hot deserts, but rather cold, eroded prairies that share some qualities with desert landscapes. The Badlands are composed of volcanic ash and sedimentary rock that was deposited over millions of years. This rock is very soft, and rain, though infrequent, erodes it rapidly into an extraordinary maze of sharp ridges, gullies, and pinnacles. Prehistoric fossil beds in the Badlands contain some of the richest deposits of early mammal fossils in the world. Among the creatures whose bones lie in the Badlands sediment are species of ancient horses, rhinoceroses, saber-toothed cats, and other creatures that walked these ancient lands millions of years ago when the climate was very different, and we can take a moment to notice. Fact 112. Desert sounds at night include some of the most peaceful in the natural world. The low hum of wind across dune crests, the distant mournful call of an elf owl from a saguaro cavity, the soft scraping of a gecko moving across a warm rock, the almost imperceptible click of cooling rock as the temperature drops in the first hours after sunset, and above all this, the profound silence that characterizes deserts, a silence so deep that you can hear your own heartbeat, your own breathing, the gentle sound of your own presence. In the world, there is nothing like a desert night for reminding a person that quiet is not empty. Quiet is full of small sounds, small movements, small lives going about their ancient business. Under the stars, there is no need to rush. Fact 113. The relationship between deserts and art has been long and productive. The American abstract painter Georgia O'Keeffe moved to the New Mexico desert in 1929 and was profoundly shaped by its landscape, its bleached animal bones, its austere geology, its extraordinary quality of light. Her paintings of desert flowers, bones, and sky are among the most celebrated. In American art, the Moroccan desert inspired Paul Bowles, who spent much of his life in Tangier and wrote about the desert as a place of both beauty and danger. Many photographers have been drawn to desert landscapes for the clarity and geometry of their forms, the perfect shadows, the uncluttered sky, the absolute honesty of a landscape with no trees or buildings to complicate the composition, slowly, gently. Fact 114. There are very few places left on Earth where the night sky looks truly dark. Light pollution from cities and towns has brightened the sky over most of the inhabited world, washing out the stars. But in the great deserts, the Sahara, the Atacama, the Namib, the Gobi, the Australian Outback, far from cities and roads, the sky at night is as dark as it was before electricity. On a clear desert night, with no moon, you can see perhaps 2,500 stars with the naked eye, compared to perhaps a few dozen from a city. You can see the Milky Way as a bright band stretching from horizon to horizon. You can see the Andromeda Galaxy as a faint smudge of light. That is the light from 2 trillion stars, 2.5 million light years away, reaching your eyes across unimaginable distance to arrive at this quiet, dark desert. And we can take a moment to notice. Fact 115. The Milky Way itself, our galaxy, is shaped somewhat like a flat disk with a bulge at the center, and we are located about 2/3 of the way out from the center in one of its spiral arms. When we look at the Milky Way from a dark desert, we are looking inward toward the galactic center, toward a region densely packed with hundreds of billions of stars. The dust and gas between us and the center block our view of most of them, but the combined light of the nearer ones creates that luminous band across the sky. The galaxy is enormous, about 100,000 light years in diameter. If you could travel at the speed of light, 300,000 kilometers per second, it would still take 100,000 years to cross from one side to the other. The desert sky opens a window onto this quiet enormity. There is no need to rush. Fact 116. The scale of time in the universe is something that desert landscapes help us feel in a small way. A rock in the desert has been there in some form for millions of years. The sand around it has been sand for thousands of years. The dunes shifted last week, but they were first formed centuries ago. The aquifer beneath the desert filled with rain during a wetter age thousands of years Before the pyramids, the galaxy above us has been rotating for billions of years. All of these timescales are real, and they all coexist in the same quiet moment, the moment of now. In a desert, under the stars, the universe is ancient, beyond comprehension, and the desert, more than almost any other landscape, holds the traces of that antiquity in its rocks and dunes and still, clear air, slowly, gently. Fact 117. We are made of the same elements as the desert. The calcium in your bones was forged in the heart of a dying star. The iron in your blood, the same iron that colors the red sands of Namibia and Mars, was created in a supernova explosion billions of years ago. The silicon that makes up most of the sand in a desert is the second most abundant element in the Earth's crust, and it was laid down when the solar system was young from the dust and gas cloud that collapsed to form our sun and planets. You are, in a very real and beautiful sense, made of the same material as the desert. The atoms in your body have been part of stars, planets, oceans, rocks, and sand before their current, temporary arrangement as you, and we can take a moment to notice. Fact 118. The desert has inspired some of the most profound philosophical and religious thought in human history. Many of the world's great religions have deep roots in desert landscapes. Jesus spent 40 days in the Judean desert. The Prophet Muhammad received the first revelation in a cave near Mecca. The Hebrew Exodus was a journey through desert wilderness. The desert fathers of early Christianity retreated to the Egyptian and Syrian deserts to seek clarity and peace. The desert strips away distraction. It removes the noise and busyness of ordinary life and leaves you with the essential: sky, rock, sand, sun, and silence. In this stripping away, many people have found or sought something profound. The desert, as a place of spiritual clarity, is one of the oldest and most universal of human ideas. There is no need to rush. Fact 119. The desert teaches patience. Everything in the desert operates on long timescales. A lichen grows a millimeter per year. A dune migrates a few meters per season. A rock weathers over millions of years. An aquifer fills over tens of thousands of years. Even the dramatic events of the desert, a flash flood, a hubbub, a desert bloom, are brief moments in long, quiet rhythms. To live in the desert or to study the desert is to learn, to think in long timescales, to accept that change is real but slow, that patience is not passivity but a form of deep attentiveness. The desert does not hurry, and in its unhurried pace, it accumulates extraordinary beauty, extraordinary history, and extraordinary life. Slowly, gently. Fact 120. And so, we arrive at our final thought. Together, deserts exist because of the gentle, ancient physics of our planet, the sun warming, the equator, air rising and carrying moisture away, dry air sinking at the subtropics, mountains blocking moist winds, cold oceans chilling the coastal air. These forces have operated for hundreds of millions of years, creating and destroying and recreating desert landscapes in slow, patient cycles. And within these seemingly harsh places, life has found extraordinary ways to persist. Patience, adaptation, efficiency, beauty. These are the lessons of the desert. The desert does not fight the conditions it finds itself in. It simply exists within them, slowly, gently, over enormous stretches of time. And that, perhaps, is the most peaceful thought of all, to carry with you into sleep tonight. And now we can let things grow very still, very quiet. We have been to the Sahara and the Atacama and the Namib. We have seen the stars over a dark desert sky and heard the low hum of singing sand and thought about the patience of a lichen on a rock growing 1 millimeter per year and the ancient water sleeping in aquifers underground, waiting. There is nothing left to do now but rest. The desert is very quiet tonight. The sand is still, the air is cool, the stars are out. Slowly, gently. If there are any thoughts still drifting through your mind, you can simply let them pass. Like grains of sand moving across a dune in a gentle wind. They come and they go, and the dune remains. There is no need to hold on to anything tonight. The facts are all settled now. The science is quiet. The desert is ancient and patient. And you are safe and still and warm. Slowly, gently. Goodbye. Sleep well. And if you've enjoyed tonight's journey through the desert, a gentle like and subscribe would mean a great deal. But for now, rest. That is all that matters. Good night.